Welcome to a lesson with Dr. Powell. Let's take a look at how related rates problems can be solved by just looking at this idea of derivative of volume is equal to area of cross section. For instance, suppose we have a conical tank and see its radius, it poses 1, its height is 3. And let's suppose that right at the height of 1, or when the height is 1, and we have maybe something being poured in at a rate where V is actually this volume right here of the liquid or water, perhaps, is suppose it's something like 2 cubic feet per minute or something like this. Okay, so maybe we're interested to know, this is height, what is dH dt precisely when the height is 1? Now, to do this, really all we need to know is, first of all, what is dV dH at h equals 1? How is this going to help us with that? We'll get to that. But first of all, let's use this idea that the derivative of increasing volume in the direction of h is going to be right here at this h value of 1 is going to be precisely the area of that cross section. So, well, when height is 1, the radius is going to be 1/3 of that height because we have this ratio 3 to 1. So it's going to be 1/3 of that. So suppose this is so 1 and 1/3. We know the radius there. Well, guess what the area is right here then? The area is just pi times 1/3 squared, which is just pi over 9. So that means dV dH is equal to pi over 9. We are actually almost done, believe it or not, in figuring out what dH dt is. Let's think of why. The ratio of how much volume changes to how much height changes per a given same unit of time is the exact same as taking the rate of change per that unit of time, or how much per that time, divided by dH per that time. You can think algebraically, this is like taking 1 over, I mean, if these were actual quantities that we were, and looking at specific ratios where these are constant ratios, this would work. And in using differentials and tangent lines at points, these really are a constant ratio at a specific value of t along their tangent lines. So we have dV dt over dH dt is actually equal to dV over dH, which is equal to pi over 9. And we know what dV dt is. dV dt is 2. So we can solve for dH dt, multiply it over, divide by pi over 9 over here, and we end up getting 18 over pi is equal to dH dt. And the units of this are feet per minute. Thanks for watching.